Buenas tardes.
Buenas tardes.
I think that's about as far as my Spanish goes.
Great.
I'm really sorry. I'm going to use notes. It's going to be, there's been some wonderful speakers today, but I'm going to save you all the embarrassment of me not getting it right by using my notes. What an amazing day. There's a lot of information today. So thank you all very much for taking the time to listen to what I've got to say. We're interested in the electrical engineering, power networks environment on mines. So everything I say today is in that context. We were a little bit narrower than you may have heard from a lot of your other presenters today. Does it work? It does work. So heavy industrial processing plants that are operating complex high and medium voltage power networks have two main technical environments, and we've heard this a lot today. We've got the IT, and the IT, as we've heard again today, is very well invested in. Over the past 2 decades, it's benefited from sustained investment from the likes of yourselves, innovators, vendors, industrial enterprises. And the results are a stable foundation that enables scalable data, warehousing, and advanced analytics that consistently support high-value business outcomes and executive decision-making. And then, of course, the other one is the OT. Now, they don't all look like that, but you would be surprised I've seen a few that do. And the OT environment in the electrical area is actually, in contrast to the IT environment, it remains fragmented, and it's very difficult to standardize at an enterprise level, at least. So the chronic underinvestment is the main area, which has left many organizations reliant on aging or non-digital or partially digital equipment that cannot easily be integrated into modern data platforms. Even where the OT assets are digitally enabled, inconsistent communication protocols and vendor-specific implementations frequently cause data gaps. Over-reliance, the second part of this, is over-reliance on existing incompatible systems, and we heard a lot today about lots of different systems not talking to each other. And that would include SCADA, in our case, large historians used to bridge this divide. Both often make the problem worse. These platforms are typically expensive, complex to deploy, and limited to processing areas only. As a result, partial visibility and data silos are normal for electrical energy and power data. The consequence is that no reliable enterprise-wide single source of truth exists to support critical operational functions or informed management decision-making. And even when data does exist, information is a very different thing. And again, we've heard this today. And while we see many clients with a lot of data, we rarely see them with high-quality, problem-specific information that directly leads to outcomes which can drive real change. So, how do you fix it? Who can fix it? Well, it's not really the IT department's job, whose remit rarely crosses over into the electrical OT environment. And the operations teams are usually budget constrained and focused on production. So the fix must come from the ability of the IT team, the engineering team, the commercial teams to get together, to use all their experience, explain this experience to data scientists for what is actually needed in order to be able to present the information and the conclusions that are needed. And that's what Vault Vision has done. Vault Vision is a cloud-based energy management and power analytics platform that developed a retrofit data extraction solution which requires no shutdowns to provide quick electrical energy transparency with decision support, without large CapEx outlays, or any CapEx outlays in most cases, and with a very quick return on investment. And I'm going to explain to you how we do it through 2 case studies. The first of our case studies was a large Zambian copper mine, This was a 198 megawatt grid supplied. The challenges of this mine were numerous, actually, and it looked a little bit like that. The mine is split into 3 sites over a wide area. There was a mixture of analog and low-tech equipment, so no site connectivity. And the result was restricted access to data, zero information about performance available. The first critical step in our process is the design. We visit each site to carry out a feasibility study, gathering information ourselves about existing equipment and the communications available. We work really closely with the client to deliver a design focused on maximizing what is already available on site. So we can work with most electrical equipment that's there, regardless of the age or manufacturer. You don't need to replace it. That's really important. Meaning there's no changes to the equipment that's on site and no unnecessary capex. We're an OpEx business. In this case, the design included 20 substations and over 450 metering points, so it was quite a big installation. Our team of high-voltage electrical engineers will visit the site to carry out the installation, and we use 2 main pieces of equipment. A secure IoT, which can read up to 30 meters, 1 per substation. We operate using Modbus and RS485 to read the data and can extract all the data points in the meter up to every second. We use 23, in this one we use 23 IoTs. Where the meter is analog or has no comms ports available, we can use clamp-on meters that attach directly to the VTs and CTs that are already in place. So there's no unplanned shutdowns. In this installation, there were no unplanned shutdowns, and there rarely is, or there isn't, and the data was flowing within 7 weeks. So it's quick turnaround. The result, data that we collect is raw, directly from the source. It's transferred through the client network to our Azure cloud database. The amount of data that we're storing, cloud databases are much more cost-effective, flexible solutions compared with keeping it on site. And our verification process is initially done by hand to establish exactly where the data is accurate, and then it's automated and checked every day. So the result is all the data is stored in name and time aligned, meaning we know when and where it was generated. This creates what we call the single source of truth, power or energy footprint. And with that, we're able to deliver a complete visibility of where every kilowatt's come from and has gone to, meaning we're providing services like energy transparency across their entire electrical network, allowing analysis of usage patterns and ultimately identifying inefficiencies. Let's bring down the costs. Automated billing verification, the ability to check monthly billing using auditable data. I know it sounds crazy, but you'd be amazed how many people can't do that. We are monitoring usage against contracts, so to identify contract breaches, so reducing fines, warning in real time of potential billing increases as they start to happen, so you can reverse the trend. And then things like maximum demand monitoring, where we firstly manage down usage spikes, leading to a reduction in fines. Ultimately, we're looking to lower the maximum demand capacity threshold. A big part of what we do is, and our customers like, is the automated reporting. So customized reporting, we create reporting structures that are completely automated and designed with our clients in mind. So in this case, we work with the electrical team, the engineering team, and the finance team to create accurate, highly detailed reporting that benchmarks against KPIs and critically is available and downloadable anytime from anywhere. So if you're on break, you can get it. Quite a lot of this information is locked on site. It's much harder to get it. The client now can identify power quality related faults using our historic analysis tool. Now, this allows historic search and comparison of power data sets independently or against each other, helping to understand fault cause and provide decision support for correction. It's really hard to actually understand where an electrical fault's come from. To be able to go back and track and see what's happening is very important. And we're now managing their power factor by providing the ability to identify, locate, and size correction equipment and managing ongoing correction. And the result is an improvement, in this case, hold your ears, of 0.85 leading, and we're now up at 0.94, and we'll be at 9.9 by the end of the year. The second site, I suspect, is probably more similar to what we find here. This is a tier 1 mining company. It was a hybrid site, 55 megawatt diesel, 36 solar, with 8 megawatts of battery. Modern metering, a lot of intra-site communications, that was all good. A large existing on-site database full of data. But the database was sourced from disparate existing systems, including SCADA and a number of others. Much of the data was unverified, so hard to class as accurate. The data was not being used, no visualization at all, no analysis or automation. A few members of staff were using Excel to generate some basic conclusions, so they had a massive database and they weren't using it. Thus, even though there was data, there was no real information generated to assist operational improvements, which is what we're all about. Okay. So the solution that we gave these guys is broken down into 3 areas. This client obviously had data, so it was important we didn't replicate what already existed. And that would be an inefficient use of funds or resources. So we carried out a full audit of what was available and what we could use. Through this, we identified where data gaps were. That's what's nice about what we do is you don't need to use it everywhere. You may just want to use it in a specific vertical within your processing plant. So we designed and targeted for the gaps that were in place in this particular site, and specifically those were 2 generator banks covering 15 generators, so quite important. And we connected up to the plant via API because we could use the data they were already generating. All of this data was integrated into our cloud database where our normal rigorous verification process took place, resulting again in a clean, single source of truth, footprint of energy and power data. And with the data in place, we were able to integrate our vivid visualization and analysis platform on top. And we built complete transparency for electrical energy, including generation splits across different generation sources, usage analysis across the entire processing plant. We deployed our analytics to the data much better, providing an understanding of what was happening with power quality. This includes our own algorithms and, of course, other technologies like machine learning, root cause analysis, and AI. Without the data in the format that you can use it in, we wouldn't have been able to do this, and they weren't. This enables us to provide the services that you can see here, the 3 main areas which I've mentioned before: energy transparency, power quality analytics. Power quality analytics are responsible for a lot of outages and downtime. And then, of course, automated reporting across the whole company. Again, so what do we produce for these guys? Again, the big one for this one, they really site and group level customized reporting. Being a tier 1 mining company, reporting through to head office's engineering and finance teams was particularly important. A lot of their management's done centrally. And as a hybrid, there was a big focus on power generation, breakdown for pricing purposes, and ESG. And all of that has been achieved. And the operational outcomes, we developed algorithms to identify optimal protocols for the 24 diesel generators, all made by different manufacturers that maximize their running efficiency. This includes monitoring tooling, alerting for ongoing management. Downtime analysis, in this case, the client was suffering from overvoltage and harmonics issues, resulting in outages. Our analysis has delivered clear pathways to reducing that, and they've already started to do it. And then, quite often with clients, we tailor or we co-develop products with them. In this case, we did milling efficiency analysis, where we worked with the client to develop a specific piece of analysis combining milling load data, which we receive via API into our system, with the analysis of power usage on the mills to develop algorithms that plot the best and most efficient loads from a power usage perspective. Not very popular with the production teams, but this was monitored and displayed in real time, but also used by the group electrical and power teams to monitor how power is being used by the processing department, and ultimately, again, to reduce costs. So the benefits of what we do are multiple, they're not always direct. For example, our automated reporting at Barracks Lumwana project, 162 man days, unbelievably. Power reduction at Caledonia Mining, we actually did a full scope study using it. After 6 months of data, we could get into exactly what was happening on site. We got into 9% of their static power consumption. This was specifically around the pumping station, so we were able to save them 3%. Billing verification, milling efficiency, as I mentioned before at Sukari, 2% of static power, and power factors and maximum demands. There's many of them. And on the way in, it's often very difficult to find out exactly what it is that we are going to find. So in summary, because I'm out of time, Vault Vision helps clients build a single source of truth data footprint for energy and power usage, converting this into information that can be used across your operations to reduce costs and improve efficiency.
Thank you so much.
Gracias.
A warm applause. Gracias. Thank you, Manoli. It's a wonderful. We have a diploma for you from Eduardo.
Gracias.
Yes, that's great. Interesante cómo lleva de la teoría a la práctica toda esta importante recolección de datos y la facilidad y la transparencia que le entrega a los tomadores de decisiones. Muy interesante. Práctico, conciso, excelente Vault Vision.